Hey, welcome to Math. Mr. Jorgens here. We're going to keep going in section 3.1 on functions. I'm going to call this 3.1 part 2. All right, so make sure you're paying attention. There will be a few questions for you to answer along the way. All right, so we're going to be building off what we did yesterday. And yesterday we learned that a relation is a function if each x maps to exactly one y. And we talked about how to build out set mappings. If right now you're realizing that you have not watched part 1 of the Edpuzzle video yet for section 3.1, you should go do that now. Now, if we think about a graph and what this would look like on a graph. On a graph, our x-axis is the one going left to right. So the x values would be like 1, 2, 3, and 4 going across, and the y-axis would be like 1, 2, 3, and 4 going up. And so if on a graph we had an x value that mapped to two different y values, that would mean some point like say 2 could map to like 1 and 3. So if there's ever a spot on the graph where 1x maps to two different y's, like here and here, then we're going to say that it is not a function. So our rule for this is called the vertical line test. And what the vertical line test says is that a graph is not a function if a vertical line can pass through more than one point on the graph. So if there's a section on the graph like this one here where you can draw a vertical line and it passes through two different points, then it is not a function. If everywhere you draw a vertical line it would only pass through 1 or 0 points, then we're going to say that it is a function. All right, so here's two different examples of our vertical line test. I'm going to say this is example 1, the graph on the left here, and this graph on the right will be example 2. Now, we're going to be able to say it is a function if there's no place on the graph where I could draw a vertical line where it passes through twice. Like on this one right here on the left, pretty much anywhere I draw a vertical line, you'll notice that it's only going to hit that graph one time, right? There's nowhere I could select on the graph where it would hit the graph in two different points. So because of that, I'm going to be able to say, yes, it is a function. Because there's nowhere on that graph where I could draw a vertical line where it hits it twice. Now, example 2 is kind of our other case. Like in example 2, like if I draw a vertical line right there, it's hitting the graph in two different points, right? And so because it's hitting the graph in two different points, I would say, no, it's not a function. So example 1, yes, it is a function. Example 2 there, since it's hitting it in two different points on one vertical line, we're going to say, no, it is not a function. All right, here's a you try. Is it a function on number 1 here? So is that graph, that V, a function here? We should be able to see that this one is going to be a function because no matter where I draw my vertical line, the blue one's there, it's always only going to hit the graph one time. So yes, it is a function. All right, we'll look at the second one here. Is it a function, that oval there on the right? So is that oval on the right a function or not? And this oval on the right, I can draw a vertical line that passes through the function in two different places. So because of that, no, it's not a function. So hopefully we understand the vertical line test. That's one of the two main concepts we're trying to learn today. All right, the second main concept we're trying to learn today is the concept of domain and range. And the concept of domain and range is something you should have heard of before in your past math life, but it's coming back again today in the functions. And what we need to know about domain and range is the domain is the set of all x values in the function. So I want you to think domain goes with the x, and then the range is the set of all y values in a function, right? So when we're thinking of the range is the set of all y values in a function. So domain is the x, and the range is the y. That's how a lot of times we think of it in math class. Those are two definitions that are important for us to know kind of moving forward, so make sure you make a note of that now. All right, let's take a look at this example. So it's asking us to find the domain and range of graph number 1 here. And so for graph number 1, it's giving us a set of points. So if it's giving us a set of points, the way that I'm going to find the domain and range is by first listing out each of the points. So for the first one, it looks like I'm at 3 to the left. So right here, -3 as my x value, and 2 down, so -2 is my y value. So this green point here would correspond to -3, -2. And then if I look at my yellow point here, that one would correspond with -1 as my x, it's 1 to the left, and it's 0 going up and down, so it'd be 0 as my y value. My blue point right here would be 1 as my x, and up 2, so 2 as my y value. And then my red point up here is going to have coordinates of, looks like 3 for the x, so 3 to the right, and up 4 spaces. Hopefully you remember how to plot points based on the Desmos activity we did last week. Now, if I'm looking to write my domain and my range, my domain would be the set of all the x values. So in terms of the x values, for the green point it would be -3. For the yellow point it would be -1. For the blue point it would be 1. And for the red point it would be 3. In terms of the range or the y values, it would be -2 for the green, 0 for the yellow, 2 for the blue, and 4 for the red point. So my domain would be the set -3, -1, 1, and 3, and the range would be the set -2, 0, 2, and 4. All right, graph number 2 is up right now. There's 3 points on number 2. We have this green one here, we have the blue one up here, and we have this yellow one over here. So there's 3 points on number 2. Go ahead and write out the domain and the range. First, I want you to find the domain of this one. So go ahead and find the domain and enter your answer when you're ready. So if we're looking at this one, the green point would be -2, -2. My blue point would be -1, 3. And my yellow point would be 2, 0. So if I go ahead and write out my domain on this one, it's going to be the set of all x values. So that would be -2, -1, and 2. Again, my -2 is the x value on my green point, my -1 is the x value on my blue point, and 2 is going to be the x value on my yellow point. Now that we have the domain, go ahead and find the range, and when you found the range, go ahead and enter your range as an answer. Taking a look at my range, I have -2 from the green point, 3 from the blue point, and 0 from the yellow point. Typically, we'll write them from least to greatest, so -2, 0, and 3. Hopefully you're able to enter your answer there on that one. All right, our last problem for the day, or last type of question, is finding the domain and range of a continuous function where we have intervals here. So this would be a graph of a parabola. We'll learn about them later in the year. And we're asked to find the domain and range. And again, the domain is going to be the set of all x values, and the range is going to be the set of all y values. And the way we're going to do that is a little different on this one because it's not discrete set points, it's a whole continuous graph. And if you notice here, the x values, there's a point everywhere from -2 all the way to 2. Like that whole kind of range there is where the graph is covered by. Since the graph is covered from -2 to 2, I'm going to write an interval saying that x can be anywhere in between -2 and 2. And we should have learned how to write those in chapter 2. It's an and statement. I want x to be less than or equal to 2, and greater than or equal to -2, right? So that's saying x is in between -2 and 2 by saying that x is greater than or equal to -2 and less than or equal to 2. So that's kind of reusing some stuff we learned in chapter 2 about inequalities. Similarly, on the y, it's also continuous, and the highest point it's going to get to is 3 there. And the lowest point it's going to get to is -2. And it's continuous everywhere between -2 and +3. So for my range, I'm going to say that the y has to be less than or equal to 3, because 3 is the maximum value there, and greater than or equal to -2, right? Because -2 is as low as it gets there. So again, my range is my set of all y values. My domain is the set of all x values. Here's the last one for you to try. Let's start with the domain. So I have a function here in number 2. I'm going to start with the domain. So the domain on this one, the key numbers here are -2, -3, 6, and 5. So I need to start by thinking about the domain on this function. Enter your answer when you're ready. So again, the domain is measuring the x values. And if you notice the x values, the function exists from an x of -2 all the way over to an x of 5. So everywhere between -2 and 5, the function exists. So I want to say x is in between -2 and 5. So I'd say x is less than or equal to 5 and greater than or equal to -2. Now that we have the domain, go ahead and find the range of this function. And once you find the range of this function, go ahead and enter your answer. All right, for the range of this function, if you notice the range is the vertical, the y, I indicated that by green on both of my graphs here. And my y is going, in this case, between -3 and 6. So I'm going to say y is less than or equal to 6 and greater than or equal to -3. And I can represent that with an in-between and inequality. -3 is less than or equal to y is less than or equal to 6. Hopefully we learned a little bit about the vertical line test as well as domain and range today. Go ahead and you are now ready to start on the Big Ideas homework for section 3.1.